What is a marginal probability? Marginal probability refers to the probability of a single event occurring without considering any other events. Consider a sample space 1, 2, 3, 4, 5, 6, 7, 8 and 9, and one event, let's say 1, 2, 3, 4. Consider one more event 6, 7, 8, and one more 1, 7, 8 and 9. So what is the probability of the event A? It's basically the number of elements, the number of outcomes in A, and number of outcomes divided by number of outcomes in the sample space, which is 4 out of 9. Similarly, what is the probability of event B? It's the number of outcome in event B divided by number of outcome in the sample space, which is 3 out of 9, that is 1 out of 3. Similarly, what is the probability of event C? It's 4 out of 9. So when we are calculating the probability of event A, event B and event C here, we are not considering any other events. When you are calculating the probability of event A, we are not thinking about event B and C. Similarly, when you are calculating probability for B, we are not considering event A and C. So here this probability of A, P of B, P of C, these are called marginal probability. This is the probability of this single event without considering any other event. Next we'll see the union of event. The union of two or more events is a superset of the outcomes of all the events. The symbol, this symbol, cup symbol, is used to represent union. Also use the word or in place of union. We'll see with one example. Consider one event one, 3, 5, 7. One more event 1, 2, 4 and 6. The union of A and B, which is also called A or B, will be the element that present either in A or it present in B. So the elements can be either present in A or B. So that will be the union of two events. So here A union B will be 1, 3, 5, 7. Then again we have 1 here in B. So we already included 1 here. So rest of the things will be including 2, 4, 6. So this is the union of A and B. Look that we are not including 1 here 2 times, because union is also a set of outcomes of all the events, right? So how do we visualize this? Let's say we'll draw a Venn diagram. Let's say this represents A, which contains 1, 3, sorry, I'll write it differently, 1, 3, 5 and 7. And also this is event B, which contains 1, 2, 4 and 6. So 1 is common here in both the event, and 3, 5, 7 belongs to A only, 2, 4, 7 belongs to B only. So the union will be this shaded part. The whole region will be under A union B. Next, intersection of events. The intersection of events is the set of outcomes that occur in all the events. The symbol, this is the symbol, cap symbol we use for intersection. The intersection of two events A and B will be known as this A intersection B or A and B. So if we are having two events 1, 3, 5, 7 and A is 1, 3, 5, 7 and B is 1, 2, 4, 6, then A intersection B or A and B will be the element that belongs to A and the element belongs to B. So the elements that belongs to both the event A and B will be included in the intersection. And here I see we only A1 is present in A and B both. So A and B, A intersection B or A and B will be only the element 1. Let's see how we can represent this using a Venn diagram. So if this is the event A, 1, 3, 5, 7 and this is the event B, that is 1 already we have here, 1, 2, 4 and 6. So the event that is, so the outcome that is present in both A and B, this is the shaded region that will be part of A intersection B. Complementary event. Complementary events are two events where one event will occur only if and only if the other event doesn't occur, doesn't take place, right? So how do we represent complementary event? If A is one event, let's say 1, 3, 5, 7 and the sample space is 1, 2, 3, 4, 5, 6, 7, 8, 9, then complementary event A, the complementary event of A is represented as is like that, or also A C, or also we write as not A, which will be the outcomes that is not present in A. So 1 is present in A, 2 is not present, 3 is present in A, 4 is not present, 5 is present in A, 6 is not present, 7 is present in A, 8 is not present, 9 is not present. So 1, 2, 3, 4, 5, 6, 7 and 9. So yeah, so 2, 4, 6, 8, 9, this is the complement of event A. So how do you represent this in Venn diagram? So if this is the sample space and this is the event A, then this shaded region is complement of A. Right? So that is the complement of A. And of course we can also write as A union A complement is this whole sample space, right? So if we consider both A and A complement, then we will get the whole sample space. Now here we have represented it in a more nice way. So this is A, this is B this part is A but not B. This part is B but not A. And this is the part is A and B, right? We get A and B both in this region. And the rest, if you see the rest, these are the region we have. All this outer part of these two circles is not A and not B. Next is how we calculate the probability of union, intersection or complement. So we'll see with one example. Let's say this is the sample space. The event is 1, 2, 3, and in that case the complement of A will be 4, 5 and 6, right? So what's the probability of A? It's 3 out of 6, right? That is half, that is 0.5. So always the probability of A complement is 1 minus probability of A, because A union A complement is the sample space, and probability of A plus probability of A complement will be 1. So here probability of A complement will be 1 minus half, that is 0.5. So if you want to calculate in a different way, A complement also has 3 elements, right? So if we just calculate this way, like 3 out of total sample space outcomes are 6, so that is also half. Now let's consider one more one more event, that is 2, 3, 4, right? So what's the probability of B? That is also 3 out of 6, that is half. But what's the probability of A intersection B? The element that is present in A and B both are A intersection B is what? 2, 3, 4, we have 1, 2, 3. So we have 2, 3 and 2, 3. So 2, 3 is present in both A and B. So A intersection B is 2 and 3. So P probability of A intersection B will be 2 out of 6, that is 1/3. Now what will be the probability of A union B or A or B? Basically we know the A union B is 1, 2, 3 and 4, right? So probability of A union B will be probability of A plus probability of B minus probability of A intersection B. We'll see why. Because when we are calculating probability of A, we are calculating probability of this region. When you are calculating of probability B, we are calculating this region. So this is one part where this A intersection B, the probability of this part is we are calculating twice. So we have to subtract that from the probability here. So P of probability of A union B will be probability of A plus probability of B minus probability of A intersection B. Similarly, we got the probability of A intersection B here from the problem statement, and also we saw one more formula here, like probability of A and probability of A complement. If we sum them up, we should get 1. So that probability of A complement is 1 minus probability of A. We'll see one example here that contains 8 red marbles, 1 2 3 4 5 6 7 8, and 6 blue marble. What is the probability of not selecting a red marble? So how many total marble we have is 8 plus 6, 14, right? So how many red marbles we have? We have 8 red marbles, and we have total 14 marbles, right? So the probability of this event A will be 8 out of 14, that is 7 out of 4 out of 4 divided by 7. So that is the probability, which is 0.57, right? So that is the probability of selecting a red marble, right? But the question asked was probability of not selecting a red marble. So that will be probability of A complement, which is 1 minus probability of A, that is 1 minus 0.57, that is 0.43. So we'll see it in a different way. Let's see how probability of not selecting a red marble means probability of selecting a blue marbles. So we have 6 blue marble out of total 14 blue marble, right? So this is basically 3 out of 7, right? So that also will come around 4.43. Now let's look at one more example. We have a standard deck of 52 playing cards where 2 events. First event is drawing a red card, and second event is drawing a face card. We have to calculate the probability of selecting a red face card. We have to calculate the probability of selecting a red card or a face card. So first see, in a 52 card deck we have hearts, diamond, club, spade, is 4 suit, and each suit have 13 cards, right? Each has 13 cards. So total we have 26 red card. So probability of red card is 26 out of 52, that is 1 out of 1 half, that is 0.5. Now how many face cards do we have? So each suit will have Jack, Queen and King, JQK, JQK, JQK. So we have in total 12 face cards. So probability of face card will be 12 out of 52. That is 3 out of 13. That comes around 0.231. So these are 2 base events we need. Now we have to calculate these 2. Calculate the probability of selecting a red face card. Means we have to calculate the probability of red intersection face. The card that is red and face card. So how many do we have? So these are red card and these are face cards. So in total we have 6 red face cards. So probability of red intersection face will be 6 out of 52, that is 3 out of 626, which comes around 0.115, 11.5%. So that is the answer of first part. Next we have to calculate the probability of selecting a red card or a face card. That means probability of red union face. So we know the union probability formula, so that will be probability of red plus probability of face minus probability of red intersection face. So that comes 0.5 because probability of red is 0.5. Then probability of face is 0.231 plus 0.231. Then probability of red intersection face is 0.115 minus 0.115, and that comes around 0.616, which means 61.6%. So that is the answer of the second part.